Welcome to Talks at Google. I'm Brett Durrett, and today we're welcoming Eric Siegel to Talks at Google. Eric has been in machine learning for over 30 years. He's the founder and CEO of Gooder AI, as well as the founder of the long-running Machine Learning Week, a conference that's coming up in 2 weeks in Phoenix. He's known for as the best-selling author of predictive analytics and his new book, The AI Playbook. He's also a Forbes contributor and was previously a professor at Columbia University. So everyone, please join me in welcoming Eric to our stage.
Thanks, Brett. Thank you very much. Thanks, everybody, for coming. It's a pleasure to speak here. I'm going to present for you a 6-step playbook for running enterprise machine learning projects successfully through to deployment, because they usually don't get there. So here, in 20 seconds, here's why machine learning is important. Business needs prediction. Prediction requires machine learning, and machine learning requires data. Putting that in reverse, we have data, we give it to machine learning. It generates models that predict, and those predictions drive all the main large-scale operations that we conduct every day, which is why we also call these types of predictive use cases predictive AI and predictive analytics. In that way, we cut costs, boost sales, streamline manufacturing, combat risk, prevent fraud, fortify healthcare, conquer spam, and win elections. As Morgan Vaughters of Unilever put it in the foreword to my book, The AI Playbook, machine learning's practical deployment represents the forefront of human progress, improving operations with science. So it was a great opportunity to speak at Talks at Google. Thank you very much, and have a great rest of the day. Wait, actually, no, hold on a second. Isn't prediction impossible? So, the only thing certain is uncertainty. Human behavior, which is what we're predicting for many of these use cases, no less challenging to predict. How do we put credibility on a area that has the audacity to call itself predictive analytics? That's a credibility question that I'll cover partway through the presentation. And a second burning question is, look, we're making these predictive models that I show as golden eggs in the slides with machine learning, otherwise known as predictive modeling, that are then meant to get deployed into operations across industry sectors, across lines of business, for all these different kinds of operations. Does it work? Do we get there? Does it actually make a difference and change these existing large-scale enterprise operations? Actually, not usually. Most new machine learning projects fail to achieve deployment. So what's missing is a greatly needed, unmet requirement, which is a well-adopted, established framework, paradigm, playbook for running these projects from an organizational standpoint that's well known to business stakeholders. And that's what I'll be covering today. I call it BizML. But this sort of no man's land, this area, both sides are kind of saying, hey, it's the other person's responsibility. Both the data science, the tech and biz, both the data scientists and their stakeholder, their client, are kind of saying, look, that's the other person's job. And the root cause for that is that both sides are conceiving these as technology projects. They're business endeavors, they're operations improvement projects that use machine learning as an important part of them. We have to reframe the way we view these. Basically, it's a consulting gig, not a technology install, business consulting. So I'll come back to this. So I'm going to cover predictive analytics, machine learning, make sure we're all on the same page of how it works, how it delivers value. The problem, which is that it fails to deploy, the need for an organizational paradigm, and that I call BizML, and probably more fundamentally than the actual paradigm itself, is the need for deep collaboration end-to-end across that paradigm, process, practice, playbook, that is deeply collaborating with the non-technical or non-data scientist stakeholders who have ramped up on a certain semi-technical understanding of the way machine learning works. So a couple quick slides about myself. As Brett mentioned, I've been running the Machine Learning Week, previously Predictive Analytics World Conference Series, since 2009. We have a new sister conference, Generative AI Applications Summit. This takes place in 2 weeks from now in Phoenix, and we'd love to see some of you there. And I'm the founder of the startup Gooder AI, which maximizes machine learning's value by testing and visualizing its business performance. So business metrics are key here, and I'll tell you a little bit about that. I'm also a skier, and this is me skiing in Utah, and I'm just a micro risk. I'm just one healthcare consumer. So unfortunately, this is the before picture, and in the aftermath, I had ruptured my anterior cruciate ligament, rough, okay? But I don't put this up to garner your sympathy. I mean, you know, if you wanted to be a little sympathetic, there we go. I knew it was coming, thanks. No, my clinical outcome's great. I can walk on my knees, super important, because I've got 2 toddlers now. Who you should feel sorry for is my insurance company, which is essentially doing micro risk management just the same as predictive analytics deployments across industry sectors. So it's the same kind of general gist. For each individual office worker, people cleaning a window of a high-rise, putting a risk, a score, a probability on the potential for a negative outcome for each individual. Now, Eric Webster, State Farm, said, insurance is nothing but management of information. It's pooling of risks. Whoever can manipulate information the best has a significant competitive advantage. Wouldn't it be cool if we could take that same value proposition, that same idea, that same core competency, and apply it in general across industries? That's what we're doing with predictive analytics. What are the chances after you spend $2 contacting somebody with targeted marketing that they're not going to respond? You just wasted $2. That they'll defect or cancel as an ongoing customer, that they'll default as a debtor, or commit an act of fraud. So basically, by putting these kind of risk scores, or the chances of something bad happening, we're conducting triage for both healthcare applications and across lines of business and verticals and industries. And in that way, we could sort of view most of these use cases as the antidote to information overload. So it's like, look, I got so many sales leads. How do I prioritize and triage them, right? And that's what you're doing with search results, right? Google search is built on machine learning models. The order of your news feed in social media like Facebook, there's so many different posts by your contacts. Which ones are going to be of most interest to you? How does that get ordered? Filtering spam, also a machine learning model. And then very analogously, these kinds of product recommendations, movies, music, all different products. Even Match.com presented at our conference on predicting who would be your best romantic match. So I could go into like, here's the definition of machine learning, learn from data to predict, and this is what the data needs to look like, and this is the kind of insights you get. But actually, let's just jump straight to the chase here. The value proposition, the way it mechanically drives large-scale operations, which consists of many decisions, is to order and prioritize. From, in the case of marketing, instead of the highest risk, rather the highest opportunity. Sometimes when I teach, I have everybody stand up and hold a piece of paper with the size of their television. So now they get them all in order by biggest TV down to smallest, and a 0 means they don't have a television, right? But they can still watch on their laptop. And then I ask a yes/no question. How many people, something like, how many people are paying subscribers for Netflix? And then what you see is the kind of thing you see with all these use cases. You see a bunch of yeses towards the top, much more concentrated, and then it withers down to next to none of them by the end of the list. Right? This is a small sample, so it's not terribly conclusive, but that's the gist. Right? So for example, if I were trying to market something that had a close affinity to Netflix, I'd probably get a lot better bang for my marketing buck by only contacting the top third. So that's the mechanics. It's that simple. You order the list, and then you draw a line somewhere. That's called the decision threshold. So here we've ordered from left to right prospects for targeting marketing, and this is a profit curve. So it kind of makes sense. As you start at the left side in following the top arc, this is the profit you're getting if you were to be contacting with marketing the customers in that order. From left to right, most likely to buy down to least likely, you're going to get your better bang for marketing buck towards the early parts of the list, those most likely to respond, and there's going to be more yeses than nos up there. And then you're going to have diminishing returns, and to the point where you only start losing money. And in this particular case, it's a lose. If you did mass marketing without targeting, you'd have an overall negative profit. It would be a losing campaign. So you might be thinking, OK, let's draw the line here. That's the decision threshold, and that's where you would maximize profit. But this tells a story, right? And it depends on the business context. A business stakeholder might say, no, let's draw the line here. For a medium-term goal, this means we basically get to market to whatever, it's like 73% of the list for free. We break even. Arguably a lot better than marketing to 100% at a cost of $550,000. So that idea of ranking it and drawing a decision threshold, that's sort of the universal name of the game. And that's how all these different operations and decisions and treatments of us as individual consumers are determined, right? Our experience in modern society is dictated by how we're treated and served by organizations in these ways. And more, the exact method I just described is indeed being applied to make those decisions millions of times a day based on that predicted outcome for each individual. Look at whether it's above some predetermined decision threshold. And if it's high enough, then you're going to decide whether to call, mail, approve, test, diagnose, warn, investigate, incarcerate, set up on a date, or medicate. So this is how it works, right? It's pretty straightforward. So let's go to a more complete definition. We'll turn to the book. It's a real book, Machine Learning for Babies and Toddlers, which I highly recommend for babies, but not really for toddlers, because the definitions of the field are sometimes so lacking or vague or what have you. Let's turn to this practical applied definition, which is technology that learns from experience. And by experience, I mean data. Data is a recording of previous events. It's a long list of things that have happened and encodes the collective experience of an organization from which it's possible to learn. That is to say, to derive a predictive model, which can then be used to predict the outcome or behavior of each individual. An individual is a general concept. It could be a human, it could be an organizational element, it could be a satellite that might run out of battery, it could be a train wheel that might fail. Each individual customer, patient, business, vehicle, image, piece of equipment. And on that level of granularity, that's sort of what differentiates it from forecasting, which would be an overall, like, is the economy going to go up or down, or how many ice cream cones are we going to sell? This is who's going to be most likely to buy an ice cream cone. So each individual gets a number, usually in the form of probability, and the higher the number, the higher expected chance that they will click, buy, lie, or die, commit an act of fraud, turn out to be a bad debtor, any kind of outcome or behavior that could be useful for the organization in order to drive better decisions. And that last part of the definition is, of course, super key, because the number crunching isn't valuable unless you act on it. So that's the deployment piece. That's where we're actually changing existing operations, which don't improve unless you actually change them. So that's what ends up being the biggest unmet challenge, is taking the number crunching and the predictions you get from that and integrating them so that operations actually change and thereby improve. So in a nutshell, the data comes in from the left, and machine learning algorithms, also known as predictive modeling, generates that golden egg predictive model, which then, by design, is meant to be used in deployment for one individual at a time. And you provide the input, which is a bunch of independent variables, the factors, the things you know about each one individual, and then it provides a number pertaining to the probability of whatever outcome you happen to be predicting for that particular project. So for example, in marketing, you're saying, hey, should I expend the cost of contact? Should I spend $2 sending a brochure to this customer? If I do, what are the chances there'll be a positive outcome and they'll buy the shoes? So look, prediction, obviously, a valuable thing to do. So let's go to that credibility question. How well can we really predict? Nobel Prize-winning physicist Niels Bohr, prediction's very difficult, especially if it's about the future. And Jay Leno, how come you never see a headline like "Psychic wins lottery"? Okay, it's real simple. The way you put credibility on this is that you don't have to predict with extreme high confidence or precision, or like a magic crystal ball. Predicting better than guessing, generally more than sufficient to drive these large-scale numbers games that we play with business. Business is a numbers game. You tip the odds slightly in your favor, and you get this great impact on the bottom line. So let's do a quick back-of-the-napkin arithmetic to show that. Let's say you've got 1 million prospects that you're going to potentially do mass marketing to, so no machine learning. If it costs $2 for each contact, then I'm going to spend $2 million contacting everybody. And if the response rate's 1%, then 10,000 are going to respond, and I'm going to get 220 back. So I'm going to get 2.2 million after spending 2 million. So my bottom line profit is 0.2 million. Great. So how much better would it be if I targeted with predictive modeling? Well, if I had a sample of, say, 40,000, representative sample, I did marketing, I waited, I found out later who did and didn't respond. That's the training data. Those are the examples from which to learn. I know how it turned out. And from that, I generate the predictive model, and then I use it to score all million prospects and then order them from most likely down to least likely, and then draw that decision threshold. So now I've drawn the line. I'm just going to target the top echelon, the top 25%, say. And if the modeling was sound, if the data was sound, I might get something like a lift of 3. So a lift, it means it's a predictive multiplier. How many times better than guessing? So if our overall average is 1%, this hot pocket has 3%. It's a lift of 3, 3 times as many responses in general over that smaller portion. So now if I just target to that top 25%, I save 75% of the marketing cost. That means I'm, in this scenario anyway, I'm forsaking all the potential sales there, but there's so many concentrated in the top quarter. Now if I do that same bit of arithmetic that I did a second ago, it turns out that the bottom line profit skyrockets by a factor more than 5 to $1.15 million, right? No new product, no new marketing creative, right? Just more, let's call it intelligent targeting. But hold on, this model totally stinks, right? It's not highly confident about any individual. It's not saying we know this person's going to definitely buy. It's a 3% response rate. But the difference is significant, and then it pays off in this bottom line calculation. So another way to define predictive analytics is a skunk with bling. You're not writing that down? So I call that the prediction effect. A little prediction goes a long way. Predicting better than guessing, generally more than sufficient to render a great improvement to the bottom line in improving the efficiencies of large-scale operations. And it's built on these kind of discoveries from data. So if you're observed using your credit card at a drinking establishment, you're a higher credit risk in the sense of being more likely than to miss repeated credit card bill payments. Whereas if you're observed spending at the dentist, you're a lower credit risk. And if you buy little felt pads to protect the floor. How many people here have bought the little felt pads that, I'm really proud of you guys. I've never bought them myself, but I got to get around to that. So you're a lower credit risk, awesome. If you like curly fries on Facebook, you're more intelligent. And if you skip breakfast and you're a male of some age, I think a younger age range, higher risk of coronary heart disease. Not necessarily because of the health benefits of the meal, right? It's considered a proxy for lifestyle. So if you're more busy living a high-paced, stressful life, then you're both more likely to be skipping breakfast and more likely to be developing coronary heart disease. So, but even if it's not directly causal, the link there, it's a correlation, it's predictive. If you know one, it increases the chance of the other. And these types of insights serve as the building blocks. The job of machine learning, the rocket science part, is to figure out how to put all those things together. So like the TV size thing, right, that was pretty well correlated. But wouldn't it be nice to consider a whole bunch of factors together at once for each individual? That's the job of what the model does, is to do multiple variables. So I call that the data effect. Data is always predictive. As data scientists, we can sleep well at night knowing that if we get the data together and juxtapose something that was known in the past next to something that turned out to happen later, we're going to find these correlations to help predict. And then putting them together can be something like this. This is a business rule, often embedded within a decision tree. So this is based on real data from Chase Bank before they merged with JP Morgan. And it's predicting whether you'll defect as a mortgage holder. So are you going to go refinance at a competing bank? So in this particular rule is if your mortgage is within a certain range, 67 to 183,000, and your interest rate is bigger than 8.7%, and the ratio of the loan to the value of the home is less than 87%, then it puts you in a bucket which is 25.6% chance of defection. And then when you put a bunch of those rules together, It's in the form of decision upside down tree, a decision tree. You start at the top. If the answer is yes, you go left. It gets you down to an endpoint. This is about a third the size of the optimal tree, but relatively legible to human eyes. It's just a way to consolidate a bunch of business rules together. So this is one form, just to make it concrete, of what a predictive model can look like, how it can operate. One really nice, elegant way to scale this up is to have a whole population of trees and have them all basically vote. That's very effective. It's called an ensemble model. Neural networks are sort of a kind of ensemble model. Anyway, when you go to neural networks and other kinds of more numerical methods, it becomes a soup of math, and it becomes more opaque. You lose transparency. It can be harder to interpret, but sometimes, depending on the context, it can be worth it because you improve your predictive performance. They get a lot more complex than this, right? They get deeper. That's deep learning. And then this is a transformer. Obviously, did anybody here invent the transformer? Because I know a couple of you did, right? Here at Google. This is a Google talk, right? Which is the basis for generative AI. Okay, so now that we can predict as well as possible using more than just one variable at a time, then we deploy it. And this is where the money is. This is the use case. So for example, UPS predicts tomorrow's deliveries in order to optimize them. So at each of the 1,000 shipping centers in the US, they have this problem of how do I allocate all these packages into this fleet of trucks, maybe 50 trucks that are going out tomorrow morning, and get them loaded overnight so they're on time for tomorrow's departure, so that overall the number of miles driven is relatively optimal and the amount of time spent by drivers and all the time of day requirements are hit, right? The challenge is they have only partial information. So there's a lot of uncertainty because some of these packages they don't know yet, right? They're not in hand at the shipping center yet, and there's a lot of sort of information system problems and time zones differences and issues that come up, so that they don't have the complete picture late afternoon or early evening when they have to start planning and then actually loading the trucks overnight for on-time departure. So they augment the known packages with predicted ones, and now they have tentatively presumed, basically. So now I have a more complete, pretty reliable picture of what the likely deliveries are, and they can get it all done in time. And this had a dramatic improvement. That technology I just described is called package flow technology. And then in conjunction with Orion, which is the time newly introduced basically GPS driving instructions, which they go hand in hand. Because one thing to say, hey, this truck has been well packed enough that it potentially has an optimal route tomorrow. It's another thing to say it'll actually be driven optimally, right? So now we're prescribing the driving directions to the drivers. And together, this amounts to an overall savings that UPS enjoys now of 185 million miles a year, $350 million, 8 million gallons of fuel, and 185,000 metric tons of emissions. So now, this didn't come for free in the sense that it seemed like a great idea and then they just did it, right? There were a lot of battles getting it approved, and then there were also a lot of battles getting it deployed. In fact, it's the leading and then basic, almost trailing story in my book, the AI Playbook, where they did a pretty good job being proactive and anticipating the challenges of what it would mean to actually get it deployed. On the scale of things, relatively very well, but they hadn't quite followed through with the swing well enough, and they had to kind of backtrack. So there was a bunch of drama. It's like a riveting soap opera. I'm really hoping that you all read the book. But along those lines, why is that such a challenge? What's the deal, right? Why don't they get deployed? Because it's about probability in a nutshell. Predictive models, the predictive scores are typically probabilities, a number between 0 and 1 or 0 and 100, same difference. So you could consider it a probability calculator, but the world's not that awesomely excited about or comfortable with probabilities. It's arcane, it's intimidating, it's theoretical, right? So case in point, Empire Strikes Back, C-3PO, right? Very helpful. I wish I had one. And he's like, sir, the chances of navigating this asteroid field are 3,160 to 1 against, right? And then our beloved hero, Han Solo, never tell me the odds, right? And I'm like, thanks, George Lucas, right, for helping further stigmatize. Now, you would think maybe on the flip side, we've got Moneyball here, right, which glamorized the union of the beauty and the geek, successfully bridging that gap, getting the number crunching actually deployed, right? You can probably guess which actor played the data scientist in this movie. And by way of doing this, the Oakland A's baseball team did a lot better than anybody expected, given the budget of the team. But this movie and even the book are really the epitome of glossing over the math. We got to get past that. And in the case of predictive AI deployments, it comes down to these three things. So this is the semi-technical understanding that you, or if you're a data scientist, your stakeholder needs to wrap their head around. And it's really straightforward. It's what's predicted, how well, and what's done about it. It's super accessible, much more accessible than high school algebra, more pertinent, interesting, cool, right? Like, it shouldn't be a black box. We need to get involved in this level of detail, right? Which to data scientists are known as the dependent variable metrics and the deployment, what's done about it. So the first and third of these, what's predicted and what's done about it, that defines the use case, right? That's why machine learning is, Harvard Business Review said it's the most important general purpose technology of the century. And it's so widely applicable because there's so many pairs like that. You predict this thing and it helps decide on this operational decision, right? There's so many ways that it applies across sectors. So let's just step through that with, I've already been talking about targeting marketing. So you predict, will the customer buy if contacted? And then what's done is you mail the brochure. We're not quite done, but this sort of defines, at least in broad steps, the actual actionable particular way that you're going to use this awesome number crunching to actually improve the business, right? So essentially, that's the first step. In reverse planning, we want to plan for the deployment for what we're predicting and what we're doing about it. But in what you'll see is the second step of the 6-step playbook, as I formalized it, we need to be more specific about the first of those two. We have to get the business side involved in defining what data scientists call the dependent variable. So instead of just saying, will they buy, it's, okay, let's be really specific here. If you send them a brochure, are they going to buy within some set time window of 13 days with a purchase of at least 125 after shipping and not return the product for a refund within some other established time window, let's say 45 days. So all the caveats and qualifiers, right? It's one thing to say we're going to act on these predictions, but predictions of what? You have to be really specific, often at least 3 times as many caveats and qualifiers. So sort of a long run-on yes-no question. It's often a binary yes-no question. So you want to get everyone on the same page because the thing you're going to be doing about those predictions only makes sense with respect to predicting exactly the right thing with business considerations. Data scientists can't do this alone in a vacuum, in a cubicle or what have you. There's got to be deep collaboration to flesh out this level of detail. So this is an example of what I mean about this overarching theme of deep collaboration and the stakeholders ramping up on this level of semi-technical, accessible understanding so that they can actually collaborate successfully in that way. Put it another way, if you're a data scientist, if your stakeholder doesn't get their hands dirty, then their feet will get cold, right? Because it's too abstract, they don't understand it, they're not going to be ready to authorize deployment, they're not involved enough. Now, of these 3, I kind of just touched on the first and third, so now let's talk about metrics. How good is it? How good is AI? How well does it perform? And it turns out that for most projects, what happens is the data scientist makes a model and only evaluates it in terms of technical metrics. Precision recall, area under the curve. How many people know what area under the receiver operating characteristic curve is? Okay, good. If only like 20% of you are data scientists, then you're the right audience. Because I need to first talk to business people and then data scientists, or to business people through data scientists. So even accuracy is just a technical metric. And the technical metrics only tell you the abstract, pure predictive performance of the model, how well it does relatively in comparison to a baseline like random guessing. rather than what we really need is the absolute business value you could get depending on how and whether you deploy the model, which are super straightforward metrics, top and bottom line profit, revenue, profit savings, returns, whatever it is. The kind of stuff that any business person is familiar with. It speaks their language. It speaks to the actual purposes and strategic directions of the organization. And the translation from one to the other is almost never to be seen. And one of the reasons for that, so this kind of curve that we've already gone through, a profit curve, like I've been in the field for whatever, 32 or 33 years, and I've probably seen these curves like 3 times other than in my own slides. Like there's a certain pervasive problem that we haven't quite gotten past here. And then similarly, a loss curve, which often ends up being a U. In both cases, it's kind of a Goldilocks zone, not too much, not too little. Depending on how you count, I've basically seen that 0 times, but these are accessible, and they speak to the business needs. Now, I think that the biggest problem, and the thing that's preventing this from happening, is that you can't just look at a model and say it's worth $1 million. So you can, with these abstract technical metrics, you can measure how well it does in a vacuum abstractly. But when it comes to the business metrics, it depends on how you use it, how you're going to act on it, how it's going to be integrated and deployed, and therefore change business operations. That's why I'm going to show just a couple quick pictures of my early stage startup, Gooder AI, where we have the ability to draw profit curves because we allow the user to parameterize the deployment. And that's what it takes. So you can put whatever business metrics, define them however you want. You can move that decision threshold around, see how it changes competing metrics at the top, and create business inputs, and whatever pertinent business inputs make the difference, which are all totally subject to change, partly because of uncertainty, partly because of business changes that are intentional, and partly sometimes there's a subjectivity to them. So in other words, what you need in order to make this much needed abstract move, fundamental move to business metrics is a very particular type of specialized user interface to visualize the effects and get an intuitive sense of what it means to move those, change those business inputs and see how it changes the story, and then within a story, change the decision threshold. So this is why we created Gooder AI. So if any of you are working on predictive use cases and would like to be a trial early access customer, that's where we are. We're super early stage, and we're just moving to trials with sort of a couple dozen companies. So I'd love to talk to you. And also that particular sort of problem, not the solution I just mentioned, but at least the problem is laid out in my MIT Sloan Management Review article shown here, and also a little more long-windedly in the metrics chapter, which is chapter 3 of the AI Playbook that you have there. So before I wrap up and we go back to some discussion with Brett, let me actually cover the 6 steps. But based on everything I've told you, they're super straightforward. The first 3 simply correspond to those 3 things I've already been talking about that need to be understood by stakeholders. What's predicted, how well, and what's done about it, not quite in that order. So the first is, what's the deployment goal? In other words, that pair, what's predicted and what's done about it. In other words, you're starting with the end goal. You're planning in reverse. And then the second is get more detailed about that what's predicted part, right? The definition of the technical objective that the data scientist is pursuing with the number crunching. And then number 3 is the metrics, both the technical and business metrics that are pertinent and where they need to land before you could deploy. And then the other 3, so those are kind of pre-production. The other 3 are the main production steps, which have always been the same. All data scientists know these. It's always been this way ever since the 1960s when they were first using, doing credit scoring and targeting marketing with predictive models, which is prepare the data, train the model over the data, and deploy it. So training the model over the data, that's the machine learning part. Right? That's the actual rocket science. Deploying the model, though, that's the pay dirt, right? That's the part that matters. That's the whole point. That's where you're actually not only generating potential value, but capturing it. That's the thing you're planning from step 1. That's the part that ends up being the biggest challenge and the thing that most often fails to get done. But the world is super focused on the awesome rocket science. It's like we're fetishizing this stuff. And who wouldn't? I mean, it's so cool. most data scientists, including myself, got into it because it's so awesome, right? I mean, the idea of automatically generalizing from some set of previous examples and deriving patterns or formulas that actually do hold in general over new unseen cases. That's a well-defined sense of the word learn, right? Learn is a human word, but now we've defined it in a specific way that a computer can do successfully. That's the most cool, awesome type of STEM, period. Like, that's why I got into it a few decades ago. But more recently, as a business consultant, I'm more focused on step 6. And that lack of focus is the problem, right? So data scientists are like, look, this whole thing you're talking about, that's not my responsibility. That's a management issue. My expertise is to do the number crunching, make the model. Its potential value is, a no-brainer. It speaks for itself. Of course, the organization is going to act on it, get it deployed, use it. Right? That's not my job. I do the number crunching. Whereas the business professionals, nope. I delegate all that technical stuff. That's why I have data scientists, right? So the faucet and the hose fail to connect. This is the routine failure for most new machine learning projects, at least outside big tech. I don't really have the data, but it's impossible to imagine that phenomenon that pitfall doesn't get fallen into, at least in some corners of a company like Google. So it's so ironic, right? It's like we're so excited about the rocket science. It's like we're more excited about that than the actual launch of the rocket. Business professionals also put up their hands and say, well, to drive a car, I don't need to know how the engine works. I don't have to look under the hood. OK, so that's totally true. And I personally don't know how engines, I know the general concept of internal combustion, but I opened the hood of my car once, and I was like, whoa, look at all the parts. Like, I don't know where the spark plug is, but I'm an expert. I know momentum and friction and the way the car operates and the rules of the road and mutual expectations of drivers. The analogous thing here also holds true. There's a certain expertise, semi-technical understanding, in order to drive machine learning projects successfully through to deployment, which is not the rocket science part, but it takes more than a half hour. So that's the point of the book, right? It's a book's worth of material. The book's first objective is to, yes, it's organized around the 6 steps by 6 main chapters, but the main point is to deliver that semi-technical understanding to business readers and also probably help data scientists realize the sort of scope of what their clients better understand if the thing's going to get deployed. So these projects, predictive AI, enterprise ML, they're a consulting gig, not a technology install, and they depend on deep collaboration across end-to-end, a project lifecycle. I've defined it in terms of those 6 steps. I coined a really nice little 5-letter buzzword, BizML, trying to brand the concept and get it out to the world that there does need to be a very specialized practice. But more to the point, that collaboration across those steps must be deep and involve business side stakeholders, people in charge of the operations meant to be improved by a predictive model, who have ramped up on that semi-technical understanding. Thank you very much.
That was great, thank you.
Thanks, Brett.
As a Netflix subscriber, I've learned that I need a larger TV, so that was...
Oh, good, yeah.
Yeah, so
it was valuable for you.
Yeah. Wanted to get, so read the book and had a bunch of things. One of the first things that struck me is you really start with don't get attached to the solution, but focus on the problem.
Yeah.
And you give some examples of it's like, we're not, building this with AI. We're solving this problem, and we'll use AI to solve that. Mm. At the same time, like I occasionally open up a web browser and I see that AI is kind of a thing. You see a bunch of companies that are doing AI, and we even had kind of a thing earlier called I/O, and AI got mentioned once or twice at that thing. So with all of the emphasis and the hype and everything around this, what is your advice for not falling into it's the AI solution, but the problem with AI?
Yeah, so solutionism is all to a hammer, the whole world's a nail, right? Fall in love with the problem, not the solution. AI first means using AI last. I can't remember who I'm quoting there, but this is a pitfall. Like, we all like, what's your AI strategy? But you wouldn't say that, what's your Excel strategy, right? Why is that happening with AI? Well, because it's a big exercise in anthropomorphism. Right? AI's original sin was calling it AI, and if it were up to me, we would use that term only for science fiction, philosophy, and maybe anthropology of like, hey, these humans are trying to replicate themselves. I love it in science fiction, for example, but if you're trying to define a engineering goal, it has to be well defined. And intelligence is nothing but if anything, it's a word that defines humans that are very particular in many complex ways. But that sci-fi narrative, the idea that we're getting things that not only have human level capabilities in one narrow area, but in general, right? Artificial general intelligence, which I like to call artificial humans. You could onboard them the same as any employee and let them rip autonomously. That's just such a compelling narrative, and we can't quash it. But if you all have any ideas to rename the field, I'm on board with you.
I think another thing that really caught me was sort of the need to kind of measure the business impact from the work that you're doing. And I work with generative AI with sort of developer productivity, and this is kind of a consistent challenge. And I imagine that there's some things that you can apply ML to, like marketing and such, which is a little more straightforward and like understanding like what is the business impact.
Yeah.
And then there are things like developer productivity, which is notoriously challenging. But I imagine there's a lot of other business processes that are difficult to understand, the actual business impact from the actions that you're generating. Like, do you have great examples of like where you've seen this done well, or complicated situations where that's been established?
Yeah. I got a couple here. So yes, the antidote to hype is focusing on value. That is actionable change to operations or introduction of a new concrete operation, which also means measuring the value, right? You can call it metrics. Intelligence is not a metric, right? It is a subjective concept, and anytime you define it well enough to measure it, it loses its charm. Once you get the computer to play chess or drive a car, it's no longer AI the way it was intended in the first place. So you've got the goalposts intrinsically keep moving. We will keep having AI winters so long as we call it AI. But generative AI and predictive AI, or predictive analytics, and I mean, these are perfectly well-defined things, basically, and they both have value. The BizML 6-step playbook is customized specifically for predictive use cases, but the general concept applies for generative AI deployment just as well, in the sense that from the get-go, you need to have a concrete idea of how it's going to deliver value, exactly what operations is it going to enact, and then how are you going to measure that value or improvement you get there. And then you have to actually follow through and measure it, right? Which in the case of generative, which is of course much newer, predictive AI, I'd like to say is older but not old school. Lots of untapped opportunity there. Generative AI, it's relatively new, and we are seeing some use cases. I referred to a couple in a recent Forbes article, and then just to make sure I remembered the specific examples of them, since I've mostly talked about generative here. Oh yeah, so Ally Financial Bank improved its marketing campaign, creating the contents of these campaigns, the creatives, with a time savings of 34%. So they actually measured it and then reported it publicly. And the thing that's really amazing is that that's very rarely done. Like, I've barely seen that. One other one, maybe the only other one that's actually crossed my desk, is a Fortune 500 software company for customer service. And you can imagine this works really well. If you're a human customer service agent doing chat service, and then you've got generative AI like pre-drafting, and then you can use it or not use it or edit it or what have you. It turns out that improves the number of issues resolved per hour, that's a nice metric, by 14%. definitely not nothing, right? It's not a robot that's going to do everything for you, but that's certainly not nothing. And maybe more interestingly, for novice and low-skilled workers, improved by 34%, which kind of makes sense because they needed that much extra help on the job. So that is to say that what generative is not a reference to any particular technology. It's a reference to the way we're using machine learning to generate new content items, writing, video, graphics, right? So it's generating that's the use case, right? The underlying technology is machine learning, as with predictive, but instead of predicting for each, let's say, customer, it's predicting, hey, how should I change this pixel, I being the computer, as I'm iteratively generating a new image, or what should the next word be, or token, whatever, on that level of detail. So it's just you're using machine learning, probably more sophisticated machine learning over bigger data in a different way. The irony is that although the results are amazing, dumbfounding, uncanny, right? So seemingly human-like oftentimes. But ironically, that actually lends less to autonomy. In the predictive use cases, because you're improving, that's the technology you turn to, predictive, to improve your largest existing operations. So for example, for fraud detection, should the system automatically on the fly approve this credit card charge based on predicting how likely it is to be fraudulent? That's fully autonomous, no human in the loop, happens instantly. But generative doesn't work that way, right? You got to proofread everything it generates.
So it leads me to a little bit of the trying to lure you from the predictive analytics into the GAI conversation. Are you saying?
Is this a job offer?
trying to establish, like, what's your take? Is generative AI more hype than value? Or?
Oh, yeah. It's I told Brett
These are talks
in the
Google,
green
by the way.
in the green room. I told Brett if he asked me that question, I would just say yes. Next question. No, I think it's overhyped by a factor of 10 or 20, right? So, if it's 10% as valuable as the hype says, that's really, really valuable, right? But the hype, I believe, underlying the hype, one way or another, is the AGI narrative. The fact that it's going to become general human-level capability. I believe that as astounding as it is, no technology progress represents a concrete step towards AGI. That's my belief. I don't mean to say that we're not algorithmic or necessarily that we could never do it, but I don't think that we're headed that direction specifically. Right. So I'd put it another way to try to sort of temper the hype, because I do think that that narrative underlies the hype. So in putting it another way, it's become clear that these neural networks scale so well over lots of examples of human behavior, like a human wrote this word next, and then wrote this word next, right? So it's learning from that human behavior to emulate human behavior extraordinarily well in an unprecedented way. I was in the natural language processing research group at Columbia in the 90s. I never thought I'd see anything like this. It's unbelievable. But there's still this overall question of, it's like, well, how much of the overall human capability can be reversed engineered by observing a limited amount of our behavior, like a lot of our writing, right? How much? Well, obviously a fair amount, but there's got to be a ceiling on that.
Let's go to some of the audience questions. See, the next one was along the lines, it's what do you think is the biggest current opportunity area for a product or service to be improved by ML?
It's a great question. So there's this weird, there's kind of this long tail of use cases, right? So targeting marketing, in terms of marketing, the other sort of main use cases is what they call churn modeling. So predicting who's going to cancel or defect in order to expend a retention offer, like a discount that you couldn't afford to give all your customers. Prediction's the only recourse for targeting that. And that's probably the other main hot marketing application. Probably the lower hanging fruit, usually the higher potential returns, depending on the business context. Because obviously credit scoring and fraud detection. So these are sort of at the top of the tail. And then there's a million other ones. I'm not even getting into healthcare, but just like, where should I drill for oil Which train wheel should I inspect? Which satellite should I inspect that might run out of battery? There's this immense long tail. So the particular use case really just depends on the organization. What are the largest scale operations? Whatever it is, whatever that large scale operation, which generally consists of many decisions, well, it's already being conducted. So by definition, you've already been collecting or likely collecting exactly the data that you need, enough positive and negative examples from which to learn. And that's what the modeling method does. It leverages those historical cases. So there's not really, it just depends on the company and the context. But I would say that in general, it's only being tapped, especially in consideration of how often it fails to actually reach deployment and deliver value. Those failures get adeptly often, or usually get swept under the rug very well, in no small part because of the AI hype, but that's not sustainable. So there's a huge amount of untapped opportunities across sectors, across organizations. I think I'll just sort of pivot from that question to say that I think that the biggest change within the predictive space that's coming, or should be coming, is to organize lines of businesses or even companies around these predictive use cases, because you're going to get there eventually. All roads lead to the original ML uses, right? If the organization grows or the operation grows sufficiently large. But the way it works now is it's like almost an ad hoc afterthought. So the company's doing its thing, it's churning away, and then the data that now you're going to leverage is collected as a side effect of doing business as usual. So you haven't really created the infrastructure or the data collection that's really meant for this. It just so happens, it's a lot of work to take that data and put it in the right form and format to then make it useful. But instead, new initiatives, new large lines of business, even new companies could be organized from the get-go of how exactly these machine learning endeavors are going to be integrated later. So plan it, instead of it being a sort of an afterthought hack with a certain hackiness to it, have it integral from the get-go.
One thing you just brought up was talking about the difficulty of actually getting things deployed. And you actually do some informal research, I think, on your site about asking, like, why did this not get deployed or such? But like the number was a little bit depressing when I first saw it. Like what percent of models don't get deployed?
Yeah, so my partner firm, very small boutique consulting firm, Rexer Analytics, does one of the biggest periodic data science surveys. And they let me participate and help add more questions pertaining to that, like the deployment success or lack thereof. And then, yeah, when we all looked at the data together, we were all like, oh my God, right? Like it is like, woo! On the other hand, it wasn't that surprising because I had done a very similar one through KD Nuggets, which is a big data science portal, like a year prior to that. And in general, I have the sense, right? I've been running these conferences, which are all about these use cases, and a lot of them get deployed and they show the results after deployment. But a lot of presentations at any data science conference, you're kind of like, well, did they deploy it yet? Did they actually measure the value? And you sort of get a feeling over the years that maybe things really aren't actually deploying as much as people would kind of want you to believe.
And I think the reasons that you listed actually, I've witnessed these types of things happening where it's the exact disconnect between I've built this and then you need someone else to, it becomes down to a business decision, and the disconnect is, if you can do all that work up front, you can make sure that you have a successful deploy.
Yeah, yeah.
More questions from the audience. What has been your biggest learning experience with feedback loops and launching ML products that change the data landscape they operate in?
Oh, that's kind of wonky. I don't want to bore you guys, but a lot of things come up. So when the biggest technical bottleneck, the biggest technical challenge is the data prep. So the core rocket science, the actual learning from data, once you've got your data set in the right way, which is typically, for these types of projects, it's just a two-dimensional table, one row per example, and one column, the dependent variable, the thing you're the prediction goal, right? Often the rightmost column. Next to that, the thing that you found out later, whether it was fraudulent, whether they responded to marketing, whether they canceled, click, buy, lie, or die, or whatever you're trying to predict. getting into that form and format based on the way it is now is hard. And one of the hardest part of that is you kind of have to roll back time. Because what you need for each row of that data is you need to have what you knew at the time you would have liked to predict, not including anything that was found or influenced by anything that happened after, between that time and the time when you found out that they did buy or that they did cancel or whatever. So that rolling back of time thing, depending on context, that can be really, really hairy. It's called a time leak. So one way to solve that is just to take these snapshots. And I've done that with a couple clients where it's a high enough sort of online operation, like it was a social network. This was an old project before Facebook won. It wasn't Facebook. Maybe it was also for an online dating client. But just like there's so much going on that you just have to like collect snapshots for a couple weeks. And then you don't have to roll back time because you're just snapshotting it. You're just sort of logging it while it happens. So those are the kinds of considerations. That's intrinsic irony, is that the actual fun part, the cool part, the actual rocket science of creating the model is not nearly as challenging as getting the data clean and together in a meaningful way in the first place.
I think we have time for one more speed round question. So,
yeah.
LLM-based projects have unique challenges for ML development lifecycle. Is this covered in the book? And if not, what exists in the industry or on best practices?
Oh, I don't know, man. The LLM stuff is so new. So running enterprise projects, no, the book is focused on predictive. And BizML is specialized for predictive projects. Creating an analogous, more formal and detailed framework that applies for generative AI, including large language models, I think is kind of TBA, right? I mean, it's going to be a different thing. We may have to suffer some disillusionment before something like that takes a popular hold. But I haven't seen an industry best practice that looks sort of like positioned to take hold for LLMs yet.
And while the book is on predictive analytics, I would say a lot of the business practices and sort of the alignment that you mentioned, I think, is actually relevant.
The broad concepts, totally. You got to plan for the business value and the operational change from the get-go. Yeah.
All right, you did so well in the speed round. I think we get one more question.
Oh, cool.
What ongoing research partnerships between the educational institutions and corporations would be of most interest to you? Which of today's research projects do you think will be the most impactful for this workforce?
Well, the hill I'm going to die on is that educational need for non-data scientists. And at the same time, that entails an education for data scientists who kind of, it's very easy to see the forest for the trees when you're actually doing the number crunching and not really saying, look, we got to take a step back. These are the broad concepts that to me as a data science may feel like high school algebra, but from an enterprise standpoint, from a cultural standpoint, okay, let's give them a copy of this book, because we need business side stakeholders to get what I'm calling a semi-technical. So to business people, at first it feels, oh, this is super technical, but then once you look at it, actually no, it's not that bad. And then frankly, from a data scientist's point of view, they're going to be like, that's not technical at all. So that's why there's this gap, and that's where there's an education need.
All right. I think we're about at time, so thank you very much for joining us, and big round of a hand for Eric Siegel.
Thank you. Thank you.